Okay guys, quiet please. Quiet please. Semua dapat kursi. Okay, thank you very much. Assalamualaikum and good morning guys. So I take initiative to move to new rooms, new furniture, new aircon. Okay. Unfortunately, the upper LCD is not function due to some cable or connections. So they replaced with this new one. The reason why I changed the room because tutorial room number 8, the LCD is the old-fashioned one. So when you have a high definition iMac project to the screen, it's become blur. So it's not comfortable to you, it's not comfortable to me. So I have to take actions. And this is the initiative. But the capacity of this room is 48. So our class is about 58, minus 1, 57. One student withdraw. And some of the students not coming like a biscuit. Sometimes they are on the table, but sometimes not on the table. Okay, the attendance like a biscuits. So it's about roughly, we need about another 8 chair, like our miss behind there. I hope you can cope with it. If you want to get a desk seat beside me, you can come early. So when they come early to the class, nobody want to sit beside me. I don't know why. There's 2 empty chairs over here. Okay, but I don't know why maybe they're scared or they're shy. Maybe I'm too old enough. I don't know, whatever reason it is. But the important thing is you learn something from today, because this year is 2022. It's quite different when I was in undergraduate in 1980s. Okay, 1980s we don't have such facilities like this. Okay, just a green board, white chalk, and the lecturer writing up. Not even we don't have any whiteboard or marker pen. We don't have that luxuries. Okay, but today is different. Anyway, we move to slide number 23. Okay, so this is the examples of a very open questions. Okay, you are given mathematical models as shown here, which is a open loop. Okay. Example 1. You can print the slide, or if you don't want to print, you can use your iPad or your handphone. The last minimum source that you have. So this is the open loop transfer functions. Can you see behind me? Okay, clear. We have open loop zeros at -3, and you have open loop poles at 0, -1, and -2. So this one is look at the poles at the origin. So it indicates system type 0. Bro. System type 0. Okay. So meaning that the velocity error constant is kV. There. And the steady state error is 1/kV. So you must understand the concept when you're given open loop transfer functions. Jangan kebil-kebil tak tahu apa. Tahu what is open loop zeros, what is open loop poles, what is the system type from the open loop transfer function, and is connected by the feedback, meaning that we have a bootload open loop and we have a bootload closed loop. We have two types. One is for open loop, the other one is for closed loop. Open loop will give 5 important informations. Closed loop will give 3 important informations. Okay. So in the test and in the final exam, you are not required to plot the bootload. Bootload is given. If they ask you to plot it, it's just a sketch, a freehand draw. Okay, a freehand draw. For example, sketch the bootload for open loop transfer function below. 1 over s plus 10. Sketch, a simple one. Sketch meaning a freehand draw. Sketch is not a draw. When the question asks you to draw, meaning you have to use a full scale. You have to use a semi-log paper. Semi-log paper must be given. Okay, it's like a graph. It's like a linear graph, but it's not a linear graph. We call it as a semi-log paper. Okay, this one for draw. Sketch is freehand draw, like this. It's a freehand draw. That's why you observe my handwriting. Okay, it's not nice because doctor handwriting is always not nice. Okay, tak faham, tulis tak cepat. Okay, so sketch lah. Sketch what? Sketch the bootload, meaning bootload have to plot. One is the magnitude in decibel, and the other one is a phase in degree. Macam tu. So 1 over s plus 10. This is category what? This is a category poles at minus 10. Okay. So you draw lah. Draw into sketch. Freehand draw. Okay. Macam tu. So 1 over s plus 10. So you learned already last week or last 2 weeks how to plot it. So for 1 over s plus 10, it starts from 0 decibels and it goes down. Okay, and at minus 20 dB per decade. Macam tu. Okay, and what is the break frequency? 10 radian per second. So break frequency also known as corner frequency. Okay, break frequency is the same as corner frequency. Sama. Okay, it's the same thing. Because it starts from 0 decibel, then suddenly corner to minus 20 dB per decade at the corner frequency 10 radian per second. That is for the decibels. But for the phase degree, so you plot 45 degrees, something like that, and then you choose another color. Okay, okay, it goes like that, goes down like that, goes like that. Okay. (10 radian per second). Corner frequency for phase is at minus 45 degrees at corner frequency 10 radian per second, and 1 decade before 10 radian per second is 0.1 radian per second, and 1 decade after 10 radian per second is 100 radian per second. Okay, log scale. Frequency is log scale. You can see it here. There's an empty table if you want. Okay. Okay. Right. That is a sketch. So now you are given this plot. So we plot it. Okay. Using the code. Okay. Assume k equal to 1. Then write the open loop transfer functions. And then call the function boot g and then grid for these open loop transfer functions. Then you get this. Okay. So this is the bootload for the open loop transfer function type 1. If the transfer function is type 0, the initial magnitude will be flat at 0 dB per decade. Okay. But if the system is type 1, so it is like this. Okay, the initial slope is minus 20 dB per decade. That is the tips. Okay, if the flat initial magnitude is flat, meaning that is a system type 0. If the initial magnitude decibel is, there is a slope minus 20 dB per decade, that is a type 1. But if the initial slope is like this, minus 40 dB per decade, meaning that this system is system type 2. System type 2. Okay. Right. So this is the plot. Okay. Can see that it varies. So this is a magnitude in decibel, and this is the phase in degree. So what is the, if you want to do it manually, so you have to do one by one. First, you plot the gain K, then you plot the zeros at -3, then you plot a poles at the origin, then you plot -1, then you plot -2 poles. So at the end of the day, it will be like this, crowded. Okay, crowded. When I was in undergraduate 1980s, we have to do like this because we don't have facilities like computer, you know, sophisticated computer. So we have to draw, then we have to add each one. Okay. Then suddenly Board of Engineers give an audit so that we don't have to plot, just give the bootload and the student extract out the informations from the given plot. So that is the trend now all over the world. Okay. So you don't have to plot like this. Okay. The plot is given. As shown here. Then you are required to okay, like this, second order. Sorry, then this is the plot. Okay, the final plot. Okay. So what do we get from the open loop transfer functions? Okay, so why don't we use Matlab so that can see? Okay, so we go for Matlab. Have you installed Matlab in your laptop? One minute. One. Then install Matlab. UTM license. So this is UTM license as well. Tak keluar. Ni, mana ni? Macam mana nak plot ni? Source code. Okay. Open loop G. One multiply S plus 3. Okay. Over S plus 1 multiply. Alhamdulillah. Betul. Sama. Next. Okay guys, see here. And you have to put the grid there so that you can see the frequency data. Okay. So recorded lah. Nanti Kang tak faham. Okay, can you see? So this is a open loop bootload. Open loop. So what information we can get from open loop bootload? First is gain margin. Second is phase margin. Third is omega gain margin. Fourth is omega phase margin. And stability status. So stability status, we have three classifications. One is stable. The second one is unstable. The third one is marginal stable or critical stable. Okay. So we go to the plot here. Excuse me, listen. Go to your mouse, right click. All stability margin. Okay. So this is the phase margin, 36.9 positive. Frequency of the phase margin is 1 radian per second. Gain margin is not available, okay, because the phase is over here. Okay, so it's down here, 10 power of 1 when the phase response cut at minus 180 degrees. But 1 is enough. Positive 36.9. So it is stable because the phase margin is positive. I will talk it later. Okay, so we go for the source code here. Okay, Safwana, are you here? Safwana, nak tanya, how you get closed loop frequency response, the source code, or closed loop frequency response? First, we have to find the closed loop transfer function. So what is the source code? Let's say closed loop is T equal to Simijin. Can you help Safwana? Because she's blurred a little bit. How to get a closed loop transfer function from the given open loop transfer function? The source code. Shh, terus senyap. Volume. volume. T over 1 plus G. Itulah close loop. Mana? And then both T. Both T. Okay. So both T, can see that put the grid. It's not the same as the open loop. So what do we get from the closed loop transfer functions? Closed loop bootload. What info we can get? Number one is the tak ada margin lagi. Repeat after me. Peak magnitude. Second one is the peak frequency. Third one is bandwidth. Follow me? At minus 3 dB. Okay, so this is the plot for the closed loop transfer functions. So how we get the magnitude over here, the peak one? Peak response. Okay, so what is the value of the peak response? Chung Hoi Ki? Quiet please. 1 point. Peak frequency. Peak magnitude 3.98. Okay. There. Peak magnitude 3.18 decibel. So MP is what? MP. Chua Lei Yong. Anti-lock. Chen. Berapa? Anti-lock. 20 log MP is equal to true. MP cannot be in decibel. It's not. It is not non-decibel. So you just anti-lock lah. Berapa? 10 power of 3.18 divided by 20. Salah. Tak nampak. Dia tak nampak. Tak cakap, tak nampak. Sorry ma, tak nampak. You have to inform me. Because I can multitasking but not at maximum. Task yang ada. 3.98. Oops. 1.58. Okay. 1.58. Chong Juan. Chong Juan, 20 log 1.58 berapa? 20 log 1.58. 3.98 decibels. So the MP is 1.58, which is equivalent with the 3.98. 3.98 is in decibel. Usually sound in decibel. Sound, you know sound? Sound is in decibels. Our voice about 70 decibels, 60 decibels. Si Micin 50 decibel. I can hear her voice. Liana lagi lah 40 decibel. Senyum aja. Okay. A Asia turbo engine is 100 decibels. If you go to the airport, the turbo engine of the aeroplane 100 decibel. Ambulance, siren police 90 decibel. 90 decibels. Machine gun, pistol 140 decibel. That's why people die, ma. It's the sound. So when people say decibels is always related to the sound. How many decibels? So you as an engineer, electrical engineer, electronic engineer soon, mechatronic engineer must know lah. 1.58 is the magnitude peak and the decibel is 20 log 1.58, which is 3.98 decibel. Very low lah, 3.98. Even lower than Liana Camelia voice. Okay. And then can we go to the just now the plot? Mana plot tadi? Hilang. Mana plotnya tadi? Can you see the plot? Window. Tu, figure 1. Okay. Okay, the peak frequency, success, magnitude peak, success, and the last one, bandwidth at -3 decibel. How we get bandwidth at -3 decibels? Natra? How we get -3 decibels bandwidth from the open loop transfer functions? Janganlah kacau dia. Mouse. Mouse. Hey. Stop me. -3 decibel. Oh, go down. Stop me. So you have to do some stretching first before. Okay lah, subscribe lah. Nah, you nak try. -2.99 is -3 decibel, and what is the frequency there? 1.61. So the bandwidth is 1.61 radian per second. Okay. Understand? Faham? Faham tak? Faham Okay. Okay, the second order, okay, is here. Okay, this one I discussed already last week. Okay, so it starts from 0 and then it goes down by minus 40 dB per decade. Okay, similar to the phase. First at 0 degree, settle down at minus 180 degrees. And this one is minus 90 degrees per decade, the slope. Okay. And at the corner frequency, omega n, the phase is minus 90 degrees. Okay, so this is the examples because in second order we have zeta and omega n. The damping ratio zeta and the natural frequency omega n. And it varies from 0.1 until 1.5. Okay, so the best response in control system is 0.707 zeta. Okay, and the phase as well. Okay, give me one second order open loop transfer functions, complex conjugate zero. Give me one sample. Ahmad Tariq Sufyan Khalid. Ahmad Tariq Sufyan Khalid. Arab brothers. Arab brothers. Ahmad Tariq Sufyan Khalid. Tak datang? Sorry? Oh, exam. Imtihan. 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 Ahmad Amir Zafran. Amir Zafran. Give me one complex conjugate open loop pulse. Anything lah, anything that run in your mind. Shh, quiet please. Alah, lecturer juga nak kena bagi manja. Amir, give me the omega n frequency from this complex conjugate pulse. What? Square root 6. Square root 6. Kejut I. 2.449. Okay. Amir Zafran, zeta. (0.41). Okay. Question. Sketch the Bootload. Sketch. I want to see. Sketch. Sketch the bootload. Open look. Learning classroom, the lecturer will go from table to table. See what happened. Right, see, sketch required. Minus 40 dB per liter. To face what? Slope minus 40 dB per liter. Slope. Minus 40 face line. Face. How you draw the face? Not my face, the face of the bootload. Don't draw my face. Because I have a permanent hair damage. Do not draw my face. Baru je dah lukat. Dah buat belum? Okay. Face. This one is related to the complex conjugate poles. Complex conjugate poles. Over here, base. What is the common frequency? Okay, 1 degree before, 1 degree after. Okay. Okay. Look. Okay. How do I imagine? Is the minus 90 degrees? From the notes that I give to you. This one kan? Okay, this one is a standard graph. Okay, standard graph. And our zeta is Zafran. Our zeta is 0.41. So you see the graph between 0.3 and 0.5. This is zeta 0.3. This is zeta 0.5. So in between. Okay lah, it's okay. This one okay. For the phase lah. For the magnitude. Okay. This up to be and the corner frequency is okay. So that is for the magnitude for second order system. This is very important, guys. Please take attention, very important. Phase plot is shown here. So it's more or less something like that on the right hand side. Okay. 0 degrees, minus 90 and minus 180. Any question? Huh? Corner frequency. The one that we discussed. 2.45. 2.45. Yeah. This one is minute. Just want to test the student sleep or not sleep in my class. Okay, any question? Any question? Last one. Last one. If given open loop transfer function sketch the open loop bootload. Previously, this one complex conjugate zeros, but now I don't give complex conjugate zeros, but I give complex conjugate. Sorry, previously complex conjugate poles, but now I change to complex conjugate zeros. Okay, what is the value of the complex conjugate zeros? Abdul Rahman Ludin. Abdul Rahman. Adam. What is the values of complex conjugate zeros? S square plus 2s plus 6. Yeah, square root 5, what is it? Square root 5. 2 point. Okay. Buat dia punya sketch. Open loop bootload. Sketch. So idea or tips, there is a reverse from the first one. Reverse from the complex conjugate poles. Reverse. Okay guys, if you don't have any idea, look at me. What is the one thing to see on the left one? Same. Exactly the same. Same omega and 2.5. And thing, tadi jawab. So previously, complex conjugate poles straight and go down, minus 40 dB. So I said reverse, because complex conjugate zeros it goes up. But positive 40 dB, because when graph like this, positive slope go down, positive slope. Okay. And then this is 0 decibels. And then for the Swiss plot, as usual, we have to mark first in 90. Then put the corner caps. Okay. 1 degree before. 1 decade after. Probably okay. So what is the common thing and the different thing in our discussion just now? Common or the same and different? Different is this one is complex conjugate force. This one is complex conjugate. Common thing data. Okay. 0.01. Diana, what is the unit for testing ratio? No unit because it's a ratio. Okay. And same thing is omega n is equal to this one slope magnitude minus 40 dB per meter. Slope phase minus 90 degree per meter. This one for that. This one. Then this one slope magnitude positive 40 dB per meter. Slope for phase is positive 90 degree per meter. This one then for the complex conjugate. You must understand how to find the common thing and the difference. We have a break for 10 minutes. Okay, 10 minutes break. Kalau sketch tak payah dia punya cukup. Ha? Okay, student ask how you find the slope. How you find the slope? There. Minus 90 degree per meter. Find this angle dy dx. Dy apa? Dx apa? 180. 0.245 to 2.25 is 180. Okay, so this line 0 dy dx 90 degree over 1 degree. Positive 90 degree per meter. Okay. This one also the same. Okay. Same dy dx. Find the dy dx. D1 is 40, Dx is 1 degree. So mari dalam 10 minit rehat. Tengok. Okeylah, benda-benda lain. Betul lah. Cepat. Okay, satu. Ya, kosong Kosong 10. Berapa? Negatif 40. So dy dia berapa? Buat segitiga. 1 buat segitiga. Buat segitiga. Tengok sini. Ini dengan kira 10 dekade. Satu dekade itu consist of 10 parts. Satu dekade 10 bahagian. My age is 5.6 decade. So what is my exact age? My age is 5 or 6 days. 5 or 6 months. We could see from 1 sampai 10. Ingat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After this, 11. Stop. Log scale. 20, 30, 40, 50, 60, 70, 80, 90, 100. Lepas 100, 101, 200, 300, 400, 500, 600, 700, 800, 900, 1. The log scale. I thought you learned already in signal and system. Tapi sikit sangat. Tak deep lah. Siapa lecturer? Who's the lecturer? Signal system? Ha? Ha. Ni Nodi ni. Jangan read first. Okay. Wipe this. Uvarogen, can you wipe the what is this? Whiteboard or glassboard? Glassboard. Okay. Thank you. Okay, quiet please. Okay, we move to the example 2, where you are given open loop transfer functions. This time around, the open loop zeros is at -3. Open loop poles is at -2, and we have a complex conjugate poles. Complex conjugate poles. Felix Erickson. Who is Felix Erickson? Ada. Ismail. Complex conjugate poles values, please. Shukran. Right. So draw the open loop bootload. Okay. So for the complex conjugate poles, the omega n is 5 radian per second, and zeta is 0.2 radian per second. So you know already the shape. Macam tu. You can imagine. Kan? Tak tahu lagi nak cakap langsung. Right, so it's given the source code for the given transfer functions and the grid, and then you get this plot. Okay, this is the open loop transfer functions. So you are going to find the gain margin, phase margin, omega GM and omega PM plus stability. Let's plot. Ivan, where is Ivan? Source code, please. No need, ma. S already defined. S already defined. So see, if you don't trust me, S, see, already defined. No need to define again. G, S plus 3. Okay, thank you. Boot, G, grid. Okay. And share the screen. Bigger. Can you see? So find all stability margins not available. Okay, because there is no gain curve cross the 0 decibel line. Okay, and the phase line also not really cross at minus 180 degrees. So the status is not available. Okay, so we just plot. In this question, it doesn't ask too much. Okay. Okay, couldn't find anything here. Peak response, yes. You can get minimum stability margins, also not, couldn't be found. Okay, because the nature of the transfer functions. Let's see the closed loop. Jason? Jason, how you find the closed loop transfer functions? 1 over 1 plus G. 1 over 1 plus G. Closed loop. Jason, I advise you go and see Miss Simichin for further advice. You got confused of it, okay? Then both T, grid. Okay. What do we find here? Okay. Peak response, yes. Over here. So we get minus 19.2 decibel. The peak magnitude. Peak frequency 4.91. Okay. What is the value of MP? MP. Konyawen. Okay. And Liana, advise me how you find the bandwidth from the closed loop transfer functions, bootload. Not available. -3 decibel not available because not available. Because the response is already negative. Okay. But some of the authors said minus 19.2 is the maximum. So you reduce to -3 decibels from there. How much? Minus 19.2 is the 0 decibels. And then you reduce by -3. So meaning that minus 19.2 plus -3. Minus 20, 22.2. Okay, it's about here, 5.79 radian per second. As long as you can show at the board attachment, okay, when you receive the final exam or the final test during face-to-face, you don't have to use your handphone anymore. You don't have to use your cam scanner. You tear out the stapler and then jot down where is the -3 decibel and then insert inside your answer script. Okay, that is a new era after PKP. Okay, face-to-face. Okay, no more cam scanner. You are not allowed to bring your headphone inside the exam room. Okay. Okay, we move to the next one. Stability via bootloads. So I already exposed to you what is the gain margin, the phase margin, omega phase margin, omega gain margin, and status, stability status. So what is it? Okay, so stability of a closed loop system can be determined using bootload open loop system. As I told you before, a closed loop system is stable if the magnitude of the open loop system is less than 0 decibel or unity gain at the frequency where the phase is plus minus 180 degrees. So you are given here open loop transfer function K over S plus 2, S plus 4, and S plus 5. Okay, so plot is given. Okay, plot is given here. Okay, and then look at the response. The gain margin there, 19.5. This one, this margin. Okay, it is a 0 minus 19.5, positive 19.5 decibel. So that's how we get the value of the gain margin. Where actually is the gain margin? The gain margin occurred when the phase cross at minus 180 degrees. Where is minus 180 degrees? Is here. Okay. What is the value of this frequency? Yuki Wong? 6.14 radian per second is the omega gain margin. Frequency of the gain margin, because when it goes up, it will touch the magnitude response at that point. See, 6.114 radian per second. Understand? Do you understand? Faham? Tak faham tanya. Kita tanya, nanti dia jadi gunung berapi. Dia pendam, sampai final exam dia explode. Okay, kita teruskan. Right? So that is the omega gain margin. So with K equal to 40, phase minus 180 degrees, the gain omega gain margin is 7 radian per second. This one is from the book. This one is 6.14, also can. Okay, don't worry, also can. Like your answer lah in your test. I already marked about half of it. Okay, so the dominant poles different value, but in the range of acceptable. So full mark. Okay, is the dominant pole is -1 plus J1. Okay, but if the dominant pole is -10 plus J10, it's wrong. It's too far. Okay. Magnitude -20 decibels. The one that we get is 19.5. Why is different? Okay, why different? Because in Bootloads we have two styles of plotting. One is using straight line approximation. In Malay, penghampiran garis lurus. Straight line approximation. The second one is using real point by computer simulations. The one that we get here is real point computer simulations using Matlab. The one that we get here a little bit different is using the straight line approximation. But both answers are acceptable. Okay, no worries. So therefore, the gain margin is 0 minus -20 is equal to plus 20 decibel. And system is stable at K equal to 40 due to what? Positive gain margin. If the gain margin is positive, if the phase margin is positive, system stable. If the gain margin is negative, the phase margin is negative, system is unstable. If the gain margin is 0 decibel, if the phase margin is 0 degree, and omega gain margin equal to omega phase margin, the system is marginal stable or critical. Therefore, we increase the gain. Okay, it's possible for stability. Okay, or marginal stable. Okay, so let's say we increase the gain instead of 40 to, we increase to 378. Okay. First, we write the code. So what is the code? Mahmud? Mahmud? لا موجود. Muhammad Said Traore? Toure. Muhammad Said Traore. The Sadio Mane brothers. Congratulations. You win the FA Cup. Quite amazing. Source code, please. Source code. Haza G. Haza G. Open loop. 40 over S plus 2. Yep. S plus 4. S plus 5. Okay. Then both G. And then grid. And then share. Share. Okay. Can you see? Okay. How are we going to find gain margin from this plot? Matthew? Matthew? Right click. There you go. Okay, gain margin. Same, 19.5 decibel. Omega gain margin 6.16. Where the phase cross at minus 180. Here. Minus 180. But minus 180, 6.17 radian per second. Gain omega gain margin is 6.16 or 17. Both can be accepted. Omega gain margin occurred at phase curve cross minus 180. Faham tak? Where is minus 180? Yeah. I will share you 10 sets of test 2. Okay, then you print, then we do together. Okay, you have to print first lah. If you don't print, I cannot help. Print first, then we discuss. Like test 1 lah. But test 1, I am not satisfied lah. Performance terrible. So system is stable. K equal to 40. Listen. Firdaus. What do you do with Firdaus? Firdaus Khairul Azman. Bagus. Firdaus is the name of heaven. Good name. Muhammad FUA'AD, your lecturer. FUA'AD is Kalbun, heart. Correct, Sami? Muhammad is Muhammad, yang terpuji. Profesor Dr. Hati terpuji. Who? I'll ask you. Good names. Inshallah, good lecturers. But you have to have yourself. Firdaus, can you give a suggestion how to make the system marginal stable? How to make the system marginal stable? How to make the system marginal stable? Firdaus. Improve, increase the gain. Using variable resistor or potential. This is the schematic drawing of the variable resistor. The real device. This one have a screwdriver. Turn around. Turn around. That's it. Yeah. So, what the Firdaus said just now, is the gain. How much? You are the engineers, I am the technician. Bro, how much? Your salary is 30K, my salary is 3,000. This is technician. You are right. Previous K is equal to 40. So in order to make marginal stable, rather Firdaus said, increase the K. Increase K. The issue now is I said okay. Those how much okay can we must increase? 400. Why 400? Why 400? Justification. Engineer must give justification. If one value, we justify the value. Before your salary is because the slide says so. Okay, listen. Listen. Dia kata 400. So we increase the follow dia lah. This one So macam mana nak tukar? How to change? You use arrow in your keypad. Then you choose this one. Then you edit. Later, no. 400. Can we increase? Can we increase instead of 400? Yes, how much? 450? 450? Oh, no. We can try. Sincere answer. Sincere. Okay, guys. 450, then plot. Then grid. Okay. Then share. Okay. Okay, this is the plot. Open loop. Find the stability. Okay. Now we have a gain margin. Now we have a phase margin. What is the gain margin? Firdaus nombor 2. Positive or negative? Negative. What is the omega gain margin? Uh, 6.16 decibel. Wengjin. Wengjin. What is the value of phase margin? Negative 5.4 ayam ringgit. Astaghfirullah. Minus 5.4 degree. Phase, Then what is the omega phase margin? .66 radian per second. Jot down. 6.66 radian per. Engineer, jot down. Future engineer. 6.66 radian per second. So what is the stability status? Show me. Sorry. Marcel. Status. Stability status. Not stable. Not stable. Correct. So Firdaus, I think your suggestion is not really good because the system from stable now goes to unstable. I ask you to tune the variable resistor so that it becomes marginal or critical. So first you must know what is the target. Target is marginal stable. Marginal stable. Target. And the specification for marginal stable is gain margin 0 decibel. Phase margin 0 degree. Omega gain margin equal omega phase margin. So you get this, then you get marginal stable. The issue now, what is the key value? What is the key value? Previously 40 stable. Fine. Then reduce it, change to 450. Then we observe this one not stable. So now in between 40 and 450, give me one value. On what? On value. Simitin. I don't have anybody else. One value. On punya. 400. 338. I choose my own number. All your number is rubbish. Okay, use my number 378. 378. Magic skate. Good. Okay. Listen. Okay. Okay. Right click. Can you read between the lines? Can you observe something? Aina Wahida, can you observe something? You gain margin, please. Wahida. Shh. Zero mana? Zero decibel. Omega phase margin. Phase margin. Zero. 0 watt. Gain margin 0 dB. Phase margin 0 dB. Omega phase margin. Huh? 6 point. Omega phase margin. .16 radian per second. Omega gain margin. Omega phase margin 6.6 radian per second. Omega gain margin 6.16 radian per second. Gain margin 0 decibel. Phase margin 0 degree. So everybody look back. Marginal or critical stable, and the on number is listen. Listen. In final exam, is open-ended question. Open-ended question meaning you can suggest any value as long as it is stable, as long as it is unstable, and critical stable. So this is sort of questions. We call it as open-ended question. If Firdaus suggests 400, Safwana also 400, Atika also 400, Si Michin 400. So 4 of them are suspected to copy each other because they use the same key. Si Michin can choose 450, but she don't want because the injury time. So everything must be quick. Okay, so next time give a different value. 400 also can, 450 also can, 5,000 also can, 5 billion also can, 40 billion also can. The system will be unstable. Okay, but for stable critical, there is only the one and only one, 377, which is omega GM equal to omega BM, and the phase margin is 0 degree and the gain margin is 0 decibels. Can you capture what I delivered just now? Understand? So after this, no need to study because you already captured in your memory. Okay. Try and error. Okay. Okay. Okay, understand. So in face-to-face exam and test, how do we get the K in practical answer? So you are given the bootload here. Imagine this is the bootload. So you adjust the gain curve. You adjust the gain curve until it get 0 decibel. So I have to do, what do you call that, hands-on on that. But you need to print this one. You need to print the hard copy. Okay, in T2 discussions. At the moment you receive first. stable, unstable, critical. You receive first. Then when I ask you to print out, you print out, then we discuss in T2 in this room. So that I can move from one table to another table. Okay. It has hands on. Definitely. You have to adjust the gain curve. That will be later. Somehow in this. Lagi mana? Kita punya kelas habis pukul 7 kan? Okay, class finish and I'll see you next week. Okay, Rabu.